So our first example of solving using matrices is right here. Here's my system. X plus 2y equals 16. 3x plus y equals 8. I guess the first step is to write our system as a matrix. And remember that our coefficients go in, not the variables. So I'd have 1, 2, 16, 3, 1, 8. I have a 2 by 3 matrix here, 2 rows, 3 columns. And I'm going to put my bar here also to show that's my equal sign. Now our goal, again, is to get ones diagonally and zeros everywhere else on the left side of this bar. And if you look, I already have ones diagonally, so that's actually not too bad. But we need to get rid of this 2 and this 3. Well, one of the ways that we can do that is to try to eliminate one of them at a time. And let's start off by eliminating this 3. So my first step, and keep in mind our operations that we have. We can multiply by a constant, we can switch our rows around, we can add one row to the other. Okay, we can't subtract rows, we can add one row to the other. So the first thing I'm going to do, if I want to eliminate this bottom 3 here, is I am going to multiply my top row by -3. Right. So if I multiply my top row by -3, that gives me a -3, -6, -48, and then my bottom row hasn't changed, 3, 1, 8. All right, now that I have this, okay, I can add my rows together. -3 plus 3 is 0, -6 plus 1 is -5, -48 plus 8 is -40. All right, now this row that we got after we combined doesn't necessarily have to replace our top and the bottom stays the same. We could have this replace the bottom and make the top row stay the same. So that's what I am going to choose to do because I know I want to have this 0 and I know I want the bottom left corner to be a 0. So again, we're going to choose for this top row to stay the same and the bottom row to become 0, -5, and -40. And the reason this works is even if we put this in the top row, we could end up switching our rows around again later and it would be okay. All right, so this isn't too bad, but oh man, now this is a -5 here. I wanted this to be a 1. Let's change that. By taking our bottom row times -1/5. All right, and if I take my bottom row times -1/5, my top row hasn't changed. Bottom row times -1/5. Okay, we're getting closer. We have ones diagonally here. We have a 0 on the bottom left. Okay, that's not too bad. My last thing I have to eliminate is this 2 here. And the way that I'm going to do that, I want my 2's to cancel. I really need this to be a 2, but I really need it to be -2 because we only can add our rows together. So bottom times -2. First row hasn't changed again. 1, 2, 16. 0, -2, -16. And then if I add 1, 0, 0, okay, this, hey, let's put this in the top row. That's where we really want this to be anyway. 1, 0, 0. And then our bottom row was 0, 1, 8. All right, so after that long process and kind of confusing process, we are in row reduced echelon form. We have our ones diagonally, our zeros everywhere else. Far right column tells us our solution, which is 0, comma, 8.